Okay, I want to welcome all of you to our PolarConnect event with Mark Buesing and the NASA IceBridge program. The NASA folks were participating in an expedition with Mark in April of 2013, and this is a follow-up to that really exciting expedition. We're looking forward to this PolarConnect event on August 13th, 2013. We have a few slides that we want to go through before we actually turn this over to Mark and the team so that we get to hear about what they did out there in Greenland. But the first slide is about the internet platform we're using. It's called Blackboard Collaborate. And the slide should have changed for you, and there should be a picture showing the different features of Blackboard Collaborate. There's a list of participants on the bottom left, as well as a chat area. This is where you can type in your questions or your comments. Just type them in the white box, hit enter, and it shows up to everybody in the room. We will only have see Mark's face today. He's the one that's allowed to have video, and that will show up in the top right of the screen. All these events are archived, and we'll put them on the website when we're done. If you're joining us by phone, you can mute your phone by pressing *6 on the phone to mute it and *6 to unmute it. And if you're going to be talking today or asking questions, you just click on the talk button to open up the mic. Once you're done talking, click on it again, and that will close the mic. So that's some of the features, and we'll go over the ones that are needed as we go through, especially when we have questions. For participant introductions today, there's a few people. We know that some people might be having trouble joining on, but if you just type in where you're at and who you're affiliated with, and if you have any students or adults with you, just type them in the chat box, and that lets us know who's joined us today. The other thing we wanted to let you know is about the PolarTrek program. So why was Mark with this team in the NASA team in Greenland? It's because he was part of a PolarTrek program, which is funded by the National Science Foundation. It's teachers and researchers experience exploring and collaborating, and we place teachers with researchers in the polar regions, both the Arctic and the Antarctic. We've been funded for a number of years, and we're hoping to receive future funding as well. And Mark was part of that this program, and he'll probably share a little bit more about that as we go along. When we get to questions during the presentation, just type them in the chat box, or you can actually click on the little hand icon above the list of participants. That's like raising your hand. Lets us know if you have a question. At the end of the presentation, you can click on that again, and we'll call on you. You can talk into the phone, or if you have voice over IP, click on the talk button once to open the mic, ask your question, and click on it again to close your mic. And I think with that, we are to Mark. So I'm going to turn it over to you, Mark.
Okay. Are we on the right slide now, Janet?
You should see the PolarTrek and NASA Operation IceBridge slide 6, and you can do the slides if you want to.
Great. Well, thanks for joining, and I know there's some people that are going to listen to the archive later, so thanks for doing that too. I've been teaching physics and coaching cross country at Libertyville High School for 20 years, and it was back in April I had the chance to work with NASA's Operation IceBridge in Greenland through PolarTrek, which pairs teachers with researchers. It's a unique program that literally lets teachers participate in real, active, relevant research around the globe in the polar regions. So this talk will do a little bit about the adventure that's Operation IceBridge, but we'll also talk about the science, and very importantly for me as a high school teacher, why science, technology, engineering, and math are so important for all of our high school students, and how a program like PolarTrek really benefits all of us. So let's start with a little of the adventure. Sarah, do you have that first movie up?
Yeah, sure. You want to play it right now?
Let's play it right now. So Operation IceBridge is a 6-year airborne science mission. It may go on longer than that. We hope it does, to gather data on polar ice in unprecedented detail that will allow future scientists to better understand the complex climate of the Earth. It's no exaggeration to say that teachers and those working with teachers and parents and the folks at NASA are literally training the next generation of scientists for whom this data will be critical. Yeah, for me, it combined that cutting-edge science and engineering with this amazing adventure. As you can see, as the plane literally flies through the fjord around these icebergs on its way to gathering data. It was just really astounding, astonishing for me. It was a tremendous adventure. And this is landing back in Kangerlussuaq, and we'll do a little geography lesson next. All right, so there's Greenland.
All set, Mark?
All set. Well, Greenland is an interesting place. It makes tiny Denmark the 5th largest country on Earth in terms of, I'm sorry, the 12th largest country on Earth in terms of area. It's an autonomous country within the Kingdom of Denmark. 80% of the island is covered in ice, and we were based in Kangerlussuaq, which is in the southern region, but Operation IceBridge also operates flights out of northern Greenland at an air base called Thule, still run by the United States military. One interesting fact is to get to Greenland in the spring and winter time, you have to originate from Copenhagen, Denmark. So I literally had to fly from Chicago across the Atlantic, actually crossing over the southern part of Greenland. Hang on, we have an announcement here at school.
You're still in the building, please go to room 117. Thank you.
And to Copenhagen, Denmark, and then back 2/3 of the way across the Atlantic to Greenland. So that was an interesting and unique part of the journey, to fly back and forth across the Atlantic there. So I'm from Libertyville High School, which is located on the shores of Lake Michigan. It's really only about 2,500 miles from Greenland, but to get there I had to fly about 6,000 plus miles. And Operation IceBridge, first of all, they have a Facebook page. Everyone should go like that Facebook page. You can follow all their amazing adventures. They're going to be in the Antarctic starting in, one of you will have to help me out, it's October. What's the date on that?
That's right. We're going down October 17th to Christchurch, and then October 21st we fly to McMurdo, and we come back on December 2nd.
Oh, so for October and November, it's going to be really exciting to follow what they're going to do in the Antarctic. For the first time, they're actually going to be based on the Antarctic continent. So that'll give them a really unique perspective down there and probably allow them to gather some data that they would have always wanted to get. They also
hey Mark, can I ask you a quick question?
Yeah, absolutely.
Can you just say the slide number that you're on, since I still can't connect? You know, at least I can follow through on the PDF.
Right. Yep, I'm on my slide. Let's see. I'm on slide 10. Although in the
Okay, great. Thanks.
Yeah.
Thank you.
And then switching to the next slide, which is the screenshot of your website. They have a great website. If you're looking for information and data on how to follow them, it's there. They have an ability, especially for teachers, this is a fantastic opportunity. They have an ability to live chat with students in classrooms. And you can find that information on the website, or email me or Christy, and we can send you a link to how you can actually talk to the folks from NASA while they're flying over the Antarctic this fall. One thing people have asked me is, why is NASA studying ice? And why is our government doing this? Well, it's easy to understand, and Michael Studinger, the chief scientist for Operation IceBridge, put it to me this way. He said, it's easy to understand why we study earthquakes. there's an immediate and obvious impact on all of us. And while the immediacy might be less for studying ice, it's just as obvious why we need to study it. We need to gather data on what's happening with this ice and how fast is it melting and how much are we losing and what does that mean for us. It just might not have that immediacy, but if we don't gather the data now, who's going to build the model or who's going to be able to understand this down the road, 10 years, 20 years? Literally the students in our rooms today are going to be using this data when they need it. So that's a really neat thing. I really, as a teacher who works in the future all the time with students, I really appreciate an organization that has that kind of long-term goal, that is gathering data not for themselves, but for those generations coming behind us. I think that's really impressive and honorable. All right, so I'm on slide 11 now.
Mark,
Yeah.
Sarah.
Yeah.
What slide should we be on? Still on the NASA IceBridge page, or are you looking at those airplanes now?
I'm going to slide 11, which is the shot of the P3, the airplane.
Okay, go ahead and do that. Just want to make sure it's following through with you.
Yeah. So the way they collect data on the ice is they do it from airplanes, and they use mainly a P3 Orion, which was originally built for the Navy to hunt submarines back in the Cold War days. And one interesting feature is that that stinger on the back of the plane is a magnetic anomaly detector, so they can mount magnetometers back there and actually get an idea of what kind of rocks are under all that ice. It's pretty complicated, but they're smart folks there. They can figure those things out. When they gather data, now I'm going to slide 12. When they gather data from the P3, they're, in terms of where the elevation of the ice is, where the top of that ice is, they're within a margin of error of only a softball. When they first set out to do this, they told me that they were hoping to get within a meter of error. And gosh, they're 10 times better than that in terms of their error value. So they take very incredibly accurate data. So the P3 is about the same size as 737, maybe a little bit smaller, but just to give you an idea, it's hard to tell the scale in these pictures. Slide 13, it's designed to fly low and slow, and that's exactly what they needed to hunt submarines, and it's exactly what they like to measure ice. They want to get close to the ice, and they want to fly slow so they can take a lot of data over the area that they fly. The plane can actually fly about 4,000 miles at a time, but most of their daily flights are somewhere in the 1,600 to 2,000 mile range. Slide 14 shows you an inside view of that P3. And down the whole right-hand side of this aircraft is all the scientific equipment. And they have everything in there. If we go to slide 15, we've moved forward a little bit. You can see on the right there, just beyond Christie's head, there is the laser altimeter. They actually have two different laser altimeter systems. Forward of that are one of the radars. They have actually 4 different kinds of radar that they shoot at the ice. One can bounce off the top of the ice. One can penetrate through snow layers to get to where the solid snowpack or ice is. One can go deeper than that. And finally, they have one that can penetrate through more than 2 miles of ice and actually see where the ice interfaces with the ground. And again, they can do this with just incredible precision. They also have something called a digital mapping system on board. They take pictures, and from the pictures there's enough overlap they can create 3D images of everything they fly over and do area calculations for the ice that they're looking at. They also fly magnetometers that we mentioned and gravimeters. These are instruments that measure the local gravity field in places. Slide 16. That's a view of the digital mapping system. They take somewhere on the order of 15,000 pictures a day. And it's operated by the people that are on those flights that work for NASA and have designed this equipment and operate the system. They're incredibly smart, but more importantly, they work very hard to be smart at their jobs. I interviewed many of them in my couple weeks that I was with them in Greenland, and each and every one of them struck me as, wow, I have a student just like this in class, or I can see the student in my class doing this later in life. You know, they have that same kind of passion, that same kind of drive. And so many of them said it's not about the grades, it's about your passion, what you're interested in, and how hard you want to work. And it was really, really neat to meet those people and see how they work, understand how they work, and try to translate that back to my students, and just as importantly, motivate my students to do that in the future and to be that kind of person, you know. So it was a great experience in that regard too for me. And then slide 17, the data they collect. I mean, you can imagine if they're taking 15,000 photos in a day, how much data that is, plus the radar and the laser altimeter data, the navigation data that they need to correct for all the errors and things, and the pitch and roll and yaw of the airplane. So they gather about 2 terabytes of data per day. So for the entire spring campaign, while they were in Greenland, they gathered somewhere in the neighborhood of 200 terabytes of data. To put that in perspective, the Library of Congress occupies about 10 terabytes. All the printed material for the Library of Congress. And that was just a view of the room there in slide 17 of the where they download the data from every day from the plane onto servers and clear those drives so they can load them back on the plane the next morning. All right, let's take a break for a little adventure, Sarah. If you have the next one, the Greenland Minute 15 queued up, let's just take a break so I can rest my voice.
All right. To be running.
Yeah. So one of the things they do, this is not really the kind of sea ice that they measure. This kind of sea ice is going to disappear literally in days or a week at the most. It's real thin. But over thicker sea ice, they really try to gather a lot of data. I'll show you on one of these upcoming slides. They fly over the poles. They actually flew over the North Pole this season. Because that ice is important. Those shipping lanes might open up in future years, and people want to know about it and how much ice is up there and how does it melt and when does it melt and can you predict those kinds of things. But this video footage is from a flight we took over to Canada in Baffin Island. There's a little ice sheet there called the Penny Ice Cap, a small sheet, they call it a cap. And they are very interested in it, the folks at NASA, because they figure if they could understand how a small ice cap behaves, they might be able to scale that up to understand better how the bigger ice sheets behave. Greenland being the second largest, and then their fall campaign to the largest ice sheet, of course, down in the Antarctica. But just stunning scenery. Every day, these lucky folks get to have that view out their office window. Close that up, and we'll go to slide 18, which shows that flight over to Canada. And you can see just fly straight across the Davis Strait, and they fly back and forth across there, and they let's go to the next slide, slide number 19, which shows, I can scroll that over, which shows all the flights that they took for the, well, almost all of them. Well, this ends Friday, April 26th. So that was all the flights that they flew in the spring on the Arctic campaign. You can see they did some in the seas in the Arctic Ocean above north of Alaska. You can see there one of the flights went over the North Pole, and then a lot of data over Greenland, all those red lines, and that one little red squiggle over there on Baffin Island in Canada. So they're very interested in how that ice sheet behaves. The last thing I read is that of the 3 millimeter average sea rise in recent decades, that Greenland is responsible for about 0.7 of that, 0.7 millimeters of that 3 millimeter rise. So it plays a huge part, and it plays a huge part in climate for the northern hemisphere. And if we can understand how that affects the climate and climate change, that's going to be great. We're going to be better able to predict what's going to happen. You might notice some areas where there's a lot of red lines. Those are regions that they're very interested in gathering data on, usually around glaciers. Let's just go to the next slide real quick before I get to that. They do a couple different things on these flights. If you see right in the middle of this slide, number 20, there's just some green horizontal lines. They call that mowing the lawn, where they're just going back and forth, just trying to get an idea of kind of the big picture of what's going on with this particular glacier, the Jakobshavn. And then down the middle of that, you might see a squiggly red line. It's kind of buried under all those tight green lines. But that squiggly red line, right, where the finger's pointing, that's the actual glacier. So they'll actually follow the glacier as it twists and turns and dives to the sea, because they want specific data just on that glacier. You can see another couple of those red squiggles in the north of that slide. And then what was really interesting to me were those long tracks, and they cross there in the middle and they form kind of like a big X. Those were interesting to me. I had no idea why they were flying those patterns until someone told me, and that is to verify satellite data. They either have data from ISAT-1, which NASA put up, which is no longer operating, or the Europeans have a satellite that's up now, and so they'll literally fly the same tracks that the satellites fly and verify and calibrate the data that those satellites are taking. But you can see the satellites just fly these long, thin tracks, and in a plane you can really get in close and tight, and there's no way you could map that whole glacier, those squiggly red lines, with a satellite. And here's a close-up of that Jakobshavn glacier and how they are gathering. You can see a lot of tight lines close in, and then they spread out a little bit as you move out from the glacier. But this is one of the fastest moving glaciers on Earth. It moves as much as 20 meters in one day. And so they're very interested to understand how that works and how it behaves and how it's changing. Slide 22, more on the technological aspects of how they gather that data in terms of the laser altimeter, the LIDAR that they use for mapping where the surface of the ice is. They determine very precisely where the surface of that ice is, like I said, within the size of a softball. And they need to fly over the same paths year after year, and that's kind of what this graphic is showing, that the lighter gray track underneath is maybe a track from a previous year, and now as the plane's flying, they need to keep that plane over that same track, so they're gathering longitudinal data. You want data for that same spot for as many years as you can gather it. So that becomes very important, and the pilots rely on NASA relies on the skill of the pilots to follow those same tracks. The pilots have a little kind of almost video game that shows them where the plane is in relation to that previous track, and then their job is to keep it on there. And the amazing part about the pilots are that 90% of the time they're within about 100 feet of that center line. So they do repeat a lot of the same data and get a lot of good longitudinal data. All right, and then the fun part of the trip for me was those glacier runs, and you can see this on slide 23, these kind of picket fence as it goes up and down those glaciers, and that is just thrilling beyond belief. At times, some of those valleys are so narrow you feel like the wings are going to touch the sides of those valleys. Of course, they're not. But you kind of feel that way. And I've flown a lot of commercial flights where you're up high and flying fast. To get down low and slow is just an amazing experience. You can just kind of imagine that if you were in a plane flying through these mountains and glacial valleys and over the sea ice like that, how interesting that would be, how thrilling that would be. And they generate incredible images from the laser altimeter, the Airborne topographic mapper they call it. They can generate incredible pictures. The interesting thing about this, Sarah, if you can use your pointer, is the bottom picture. It's a glacier. You can see it's running from kind of northwest to southeast across your screen. And that was mapped on 4/4/2013. And then they flew over the same glacier 6 days later on 4/10/2013, and a 250-meter piece had broken off. You can see how that top picture is shorter in terms of the glacier. The red and orange part is shorter than the one below it. It's the same, they're just kind of overlaid on, not necessarily directly on top of each other. They're offset, so you can kind of compare the two. But that was neat. Jim Youngel, who's on, does a lot of that work. It's really amazing. And using those ice-penetrating radars, they can actually see what's underneath the ice as well. So here's a map of literally what's underneath that fast-moving Jakobshavn glacier. As a side note, after I got back in May and my AP physics classes were done with the AP exam, we actually grabbed some of this data, which is freely available for anyone in the world to use through the National Snow and Ice Data Center. We actually grabbed a piece of that data and mapped it. We used a little program we have here called Minitab, which can do a 3D plot, not nearly as sophisticated as this and not with nearly as much data as they use in some of these. But it was really exciting nonetheless, and we were the first high school in the country to do that. And hopefully more high schools can do that too. And this is a composite slide of a lot of different things, a lot of different data products that NASA can put out. On the very left, Sarah, if you can point at that black and white section, that's just a picture of the glacier. It's the glacier's coming down top to bottom, and about 3/4 or 2/3 of the way down, you can see kind of a cliff there. And that's the calving front of the glacier. From there on to the bottom of the screen, that's water, and those icebergs are floating in water. And then down below is kind of some of the things we were doing in the high school environment, kind of plotting a profile of that. Same thing, that red graph down there, but it gives you great information. And don't forget, the data that they're taking is incredibly accurate. So you can really compare these graphs and pictures year to year to year and really get a feel for how the trends are happening and make models to predict what's going to happen. And then that incredible 3D image that's rendered with color in terms of elevation in the middle there, the highlight of that map. I mean, and you can see if you compare the picture to the profile to the 3D image that Sarah's pointing at now with the little finger, how they all match up. It's really, really fascinating. One of the people on IceBridge, John Sontag, told me, he said, wouldn't it be great if some North Korean or some Iraqi scientists used the data that NASA gathered to build the best climate model? And that's the kind of global perspective that NASA has, and particularly these people on Operation IceBridge who fly around the world doing their job, that they really see this as helping everyone. This is not necessarily, the Netherlands, believe me, are just as concerned with climate change and whether Greenland is gaining or losing mass as anyone else in the world. And so they have just a great perspective. It's neat for me as a teacher to see those same kind of teaching and philosophies in the engineers and scientists there. One thing I had in on one of my presentations, which we haven't uploaded, is a great video by Alan Pope about the colors of glaciers. I'm going to paste that link in right there to the chat. If you have not seen Alan Pope's video on colors of glaciers, definitely take a look at that. It's fun to watch, and the science behind it and what he can do with just looking at colors and satellite imagery is pretty amazing. All right, so let's skip to